right, guys, here we go. We're gonna wrap it up, like a little present. Chapter 5. Chapter 5 talks about conditional probability in independence. Independence, in particular, is a really big topic. Okay, it's one that, I gotta turn this down. It's one that we have to get down, and we can with just a little formula. Okay? So, it's not intimidating, all right? We're going to walk through this. We're going to do lots of examples. That's the best way to learn this stuff, looking at examples. So, they have this first idea of conditional probability. And what they mean when they have conditional probability is the probability that one event happens given that something else has happened. Okay? So if A has happened, what's the probability that B happens given that A already happened? Okay? And the way that we draw that, okay, you have a little line here. Okay? It's a little line. It's the same height as those. I just drew it bigger so you could see. Okay? It looks like this. The probability of B given A. And that's the way that you read that. It reads the probability of B given A. Okay? So the probability that a randomly selected student is male given that they have pierced ears from some of the examples that we've done earlier in our book. Okay? So here we go. We start off with an example. Like I said, best way to look at this stuff. So if we know a person owns a home, so it's like, given they own a home, what's the probability that they're a high school graduate? Okay, so I'm going to show you a couple different ways to do this. I'm going to show you how to do it with the chart, not using formulas first, so that you have a conceptual understanding of this. And then we can look and you know, use the formulas. Okay, that's the way I like to do it. So I'm hoping that, you know, it helps you. So if we know a person owns a home, where are we looking in our chart? Well, we're looking at the homeowner row, right? And that's it. We're only worried about the homeowners, given that they're a homeowner. Given they're a homeowner. Okay? So I'm going to do these here. You can write them right in, okay? I don't want to do that because I'm going to make copies with this. Okay, but given they own a home, so we're looking at just the homeowners. What's the probability the person's a high school graduate? Well, there's 20, so given they're a homeowner, we're looking at this row, only this row. Conditional probability, you're looking at a row or a column, okay? Marginal probability, what we did way back at the beginning of the course, we're looking in the margins. But since this is a conditional probability, we're looking at a row or a column. And here, what we're given is they're a homeowner, so we're looking at the homeowner row. What's the probability the person's a high school graduate? Well, that's going to be 221 out of 340. Okay, and that is your probability. I would write it out too, and it'd be 0.65. Okay, so they probably want both of those. So let's look at the second one, and then I think later we get into the formulas. But the formula is not till here, but we can do that. We can do it. So if we know the person's a high school graduate. So now we're looking at just the high school graduates. Where are they found? They're found in the high school graduate column. So we're looking at number 2 now. What's the probability a person owns a home? Well, how many homeowners are high school graduates? That's 221. And out of the total high school graduates, which is 310, and if I were to divide that out, it would be approximately 0.71. Okay? So that's that. All right? So if you wanted to write it out, you could say, we know they own a home. What's the probability a person's a high school graduate? So you could do probability high school grad given they're a homeowner. That's the first one. And the second one, we know the person's a high school graduate. So what's the probability the person owns a home? So that's the probability that they're a homeowner, given they're a high school grad. Okay? So that's how we would write that out. That's how we write it out in symbols. Okay? And I guess they want me to wait for the formula, so we will. We'll probably come back to the same problem, but we'll do it with formulas as well. So here we go. Here's the independence rule. Okay? And probability of A given B equals probability of A, and the probability of B given A is equal to the probability of B. So independent events, way back we talked about this earlier in the course. Two events A and B are independent if one occurs has no bearing on the other one. Okay, if they're related, then they're not independent, then they're associated. Independent means, if one happens, it has no bearing on the other one. And to do that, you are going to say the probability of A given B is equal to the probability of A, or the probability of B given A equals the probability of B. Either of these, you don't have to do them both. If one works, they both work. Okay? If one doesn't work, they both won't work. Don't do both of these. Pick one, okay? Pick one of these and show that it's either true or show that it's not true. All right? So, and we're going to do examples on this. So don't say, well, geez, are we going to? Yeah, we'll do examples on this stuff. Don't you worry. Okay? So for my tree diagram, I'm going to redraw this, okay? Because I don't like the way this came out. I'm not going to throw anyone under the bus. My intern that year was fantastic. She was amazing. She actually has a job at Stats. I'm kind of proud of that. She works for a company in Worcester, and she went to UMass and studied statistics because of taking this class. So that was kind of cool. So I'm certainly not throwing her under the bus. She was amazing. Sometimes you just can't type things the way they are on paper. So this is tree diagram, so you can write in your notes or write in the side, maybe over here, okay? Tree diagrams and the general multiplication rule. So we start off by tossing a coin. We toss a coin, okay? And what happens when you toss the coin? Well, there's a chance you're going to get heads and there's a chance you're going to get tails, right? Now, we get a 50% chance of heads, or a 1 in 2 chance, and we get a 50% chance of tails, another 1 in 2 chance, okay? Let's say we flip the coin again. We flip either the same coin or you flip another coin. Well, the same thing's going to happen, right? You've got another 0.5 chance of getting a heads, or a 0.5 chance of getting a tails, and then if you happen to get a tails on the first flip, okay, because they're not related, okay, some people will say, oh, there's a better chance. You get a better chance if you got tails first. No, it's the same, man. It's the same. You flip a coin, they're independent events. The second flip does nothing to do with the first flip. You could get 4 tails in a row. And someone says, what do you think, what's coming up next? Someone can say, oh, it's definitely going to be heads. No, you don't know. It's a 50-50 shot. So that could be heads, that could be tails. 0.5 or a half. Okay, you don't have to put both of those. I'm just trying to show you the decimals as well as the fractions. So if I asked, what's the probability of getting 2 heads? Well, let's look. That means we're here and we're here. Okay, if I want to find that probability, I would take a half times a half. A half times a half is 1/4. Okay, there's a 1/4 of that happening, a 1/4 chance of that happening, 1/4 chance of that happening, a 1/4 chance of that happening, all right? The probabilities are all the same in this case. It doesn't always work this way, okay? But, when we're talking a 50-50 shot. So, probability of getting 2 heads is what, you take this and you multiply times this. Because they're independent, we can do that. So it's 1/2 times 1/2, which equals 1/4, which equals 0.25. Okay? Now the general multiplication rule, we're on to the next page already. Look, we're flying through this stuff, guys. Flying. Right? So, general multiplication rule is sometimes called joint probabilities. So that's something new. You can put that, that's in your notes. You already got it there. The multiplication rule for independent events, probability of A and B, probability of tails and tails, probability of getting 2 tails, probability A times the probability of B. Okay? So that's why we did that. And so let's look. Now the general multiplication rule, I am missing something here in the notes. So what happened was I had a gap in the notes and I just erased some stuff. So the general multiplication rule is the probability of A and B is equal to the probability of A times the probability of B given A. Okay, so that will come into play sometimes when they're not independent. Okay, so you have to consider that. If it's independent events, you can just multiply the two together. And here's our formula for the conditional probabilities, and that is on your formula sheet, okay? These are not, okay? These are not, but this one is on your formula sheet. So we get to try out an independent one here. I love the independence problems. They're easy. I hope there's one on this year's test because we're going to practice it so many times that you're going to be really good at it. Really good at it, okay? So let's look. Are the events female and allergies independent? Well, let's say that we let A be allergies, right? That kind of makes sense. And we're going to let female B be female, okay? So for them to be independent, we would have to say the probability of A is equal to the probability of A given B, or the probability of B equals probability of B given A. Alexa, pause. I'm going to pause this video for 1 second, guys.